So now we're ready for part D. We have z to the 10th divided by z to the 4th. Once again, the first thing you want to do is think about how these two pieces are connected. They're connected by division. And because they're connected by division, that means we're going to be using the quotient rule. And according to the quotient rule, if you have x to a power divided by x to a power, you can subtract your exponents. Well, again, it works for z as easily as it does for x's. So if we have z to a power divided by z to a power, we can then say this is the same as z to the 10 minus 4 power. 10 minus 4 is 6. So we have z to the 6th power. Now that's our final answer. Now, what you want to do at this point is step back and notice something special. So our highest power of z here was in the numerator. And if you look at our final answer, we have z to the 6th. Now, z to the 6th is really z to the 6th divided by 1. So notice this z to the 6th is also in the numerator. So I'm going to say that again. Our highest power of z was in the numerator, and our final answer had a power of z in the numerator as well. So that's something to keep in mind when you're doing these kinds of problems. If your higher power is in the numerator and you end up with something over here where your z is in the denominator, that means that something went wrong. And you want to revisit and figure out what went wrong. So let's keep that idea in mind as we look at part E. So for part E, we're going to have 5 to the 2nd power divided by 5 to the 6th power. Now, one thing that I could try is to use the quotient rule on this problem, but unfortunately, because of the powers that are happening here and where the highest power is, it would ultimately take me to a place where I won't have all the answers yet. So, unlike part D, on part E, I'm going to go ahead and think about this in terms of fraction ideas from the beginning of the semester. So, I have 5 to the 2nd divided by 5 to the 6th. 5 to the 2nd, that means I have 2 copies of 5 in the numerator. 5 to the 6th means that I have 6 copies of 5 in the denominator. So if I think about cancellation in terms of fractions, I have 2 copies of 5 that can be cancelled from the numerator, and 2 copies of 5 that can be cancelled from the denominator. So if I cancel those 2 copies of 5 from the numerator, I'm going to be down to the number 1. And if I cancel 2 of my 6 copies of 5 from the denominator, I'm going to be down to 4 copies of that 5. So what that means then is that I'm going to have the number 1 in my numerator, and I have 5 to the 4th in the denominator. Well, we just saw a problem a moment ago that had a number to a power, and I said that you want to think about that kind of problem and expand them whenever you can. So 5 to the 4th power means we're going to have 5 times 5 times 5 times 5. You can pull out your calculator and again do 5 times itself 4 times, or use your exponent key, 5 to the 4th power. You're going to find that that's going to be 625. So we have 1 divided by 625. So now, let's talk about E in the same way we talked about D a moment ago. The highest power of 5 in the original problem, 6, was in the denominator. And if you look at the work here, this 4 was in the denominator as well. So when you have your highest power of 5 in the denominator, that's then where your power of 5 should end at the end of the problem. So keep that in mind whenever you're doing any kind of division problem. And again, the reason that D and E were a little bit different was that D had the highest power in the numerator, but E had the highest power in the denominator.